Hi friends, today we'll discuss about the partial differential equations. What do you mean by partial differential equation? An equation involving one or more partial derivatives of a function of two or more variables is called a partial differential equation. Now we consider the concept the formation of partial differential equation, shortly called as PDE. Formation of PDE by eliminating arbitrary constants. Here we have one procedure, that is, given a relation of the form f of x, y, z, a, b equal to 0, where z is a function of x, y and a, b are arbitrary constants. Here we differentiate given relation with respect to x and y partially and eliminate the arbitrary constants a and b to form the PDE. Now here we consider one example, the simple example, that is, before that, here consider the note. Here we use the standard notations when z is a function of two independent variables x and y. For this we have the notations first order and second order, that is, p equal to dou z by dou x. We denote it as zx. Similarly, q equal to dou z by dou y divided by zy, and the second order is r dou 2z by dou x square, we denote it as zxx. The mixed order is mixed derivative, that is with respect to x and y, is s equal to dou 2z by dou x dou y, denoted as zxy. And last one is with respect to y twice, t equal to dou 2z by dou y square, denoted by zy. Now we consider the simple example. Form the partial differential equation by eliminating the arbitrary constants from z equal to x plus a into y plus b. Solution: we consider given equation. Given z equal to x plus a y plus b, call this equation number 1. Differentiate equation number 1 partially with respect to x and y. We get dou z by dou x equal to, here we are differentiating partially with respect to x, therefore keeping other terms as a constant, therefore 1 and a is constant 0, and they treat as it is constant, therefore, and we denote dou z by dou x as a p, therefore p equal to y plus b. Similarly, with respect to y, dou z by dou y, and here we are considering x plus a as a constant, keep as it is, y 1 and b 0, therefore denotation is q equal to dou z by dou y, that is our denotation is q, therefore q equal to x plus a. And substituting these y plus b and x plus a in the given equation number 1, that is, therefore equation number 1 becomes z equal to pq is required PDE. Now we consider the second example. Form the PDE by eliminating arbitrary constants from z equal to x square by a square plus y square by b square. Solution: consider given equation 2z equal to x square by a square plus y square by b square, call this equation number 1. Here also we differentiate the equation number 1 partially with respect to x, therefore differentiate equation number 1 partially with respect to x and y, we get two dou z by dou x and 2x a square as it is, and this is 0. Using denotation we get p equal to x by a square, because we can cancel 2 and 2, and similarly with respect to y, 2 dou z by dou y, dou z by dou y equal to 2 y divided by b square. Therefore, using denotation q equal to y by b square, and using this relation I will write a square equal to x by p, and using this relation b square equal to y by q. Therefore, now the equation number 1 becomes 2z equal to x square, substitute a square value x by p, and similarly y square, b square is y by q. Here 1y x cancel. Now we'll get 2z equal to px plus qy is a required PDE. Now, one more equation we consider, one more example, that is find the PDE of the family of all spheres whose centers lie on the plane z equal to 0 and have a constant radius r. Solution: here the sphere lie on the z plane z equal to 0, here we consider the sphere whose centers lie on the plane z equal to 0, that is, consider the sphere whose centers lie on the plane z equal to 0 and I have concentrated, that is x minus a whole square y minus b whole square, and here z minus 0 whole square, because whose centers lie on the plane z equal to 0, therefore z square equal to r square. Call this equation number 1. Here also differentiate equation number 1 partially with respect to x and y. We get 2x minus a plus the second term is 0. Now this is 2 times z, and with respect to the chain rule, that is dou z by dou x, and this term is 0. Therefore 2x minus a, and this side 2z, and this is denotation is p, 2 to get cancel. Therefore x minus a equal to minus zp. And with respect to y, we get first term is 0, next 2 times y minus b. Similarly, this is 2z and dou z by dou y equal to 0, and using denotation 2 y minus b equal to minus 2zq. 2 get cancel, we get y minus b equal to minus zq. Now equation number 1 becomes, therefore x minus a is minus zp, therefore whole square minus zp whole square, y minus b, that is minus zq whole square plus z square equal to r square. Here this is z square p square plus z square q square plus z square r square. Here z is common, therefore I will take z outside. P square plus q square plus 1 equal to r square is required PD